Hi, my name is Dhruv and I'm a tutor at Tutor here. And today we will be going on a lesson for linear equations. So let's get started. So what we want to accomplish in this chapter is get a grasp on what linear equation actually means, understand what is so special about them and what kind of equation can you actually call a linear equation. So here is our first linear equation, which is y is equal to 2x minus 1, right around here. So if you're seeing this for the first time, the thing that jumps out at you is y and x. Now they're called variables in which you can substitute values. So to solve a linear equation means that you have to equate the left-hand side and the right-hand side. So you have to plug in values for x and y, which makes the left-hand side equal to your right-hand side. Now, what makes this interesting is that there's not just one solution for x and y. You can have multiple solutions for x and y. In fact, you have infinite solutions for x and y to solve a linear equation. Now, the solutions, if you group them up together, a special property that makes linear equations special is that all the solutions are going to be lying on a line on a graph. So that is what we aim to prove here, to just give you an intuitive understanding about what a linear equation means and how you can prove whether an equation is actually a linear equation. So let's get started. So let's take the first value of x as 1, and it will be 2 into 1 minus 1, which will be 1 for y. And let's take the x value as 0, and 2 into 0 minus 1 would be minus 1 for y. And let's take the final value for x as 2. So it'll be 2 into 2 minus 1, which will be 3. And now let's actually plot these points on the graph to see, does it actually give you a straight line, which would prove that it is indeed a linear equation. So let's go ahead. We have 1, 1 over here. We have 0, minus 1 right over here. And we have 2, 3 right over here. So let's go ahead and actually plot this line and check whether this is a linear equation. So, yep, you can see that all these points lie on one line, and the equation for this line is y is equal to 2x minus 1. And therefore, we have proved that this equation is a linear equation. Now, let's actually try a point on the line. Since all the points in this line actually are solutions to this linear equation, let's just plug in one point and let's just verify whether this is actually the line that we're interested in. So as you can see that this line is passing through a point called 3, 5. 3 is right around here, and 5 is right around here. So this is the point that we're interested in. So let's actually plug in the value of x, and let's see whether we can verify the value of y. So x in this case is 3. So let's write this out. Y is equal to 2 into 3 minus 1, which should be 6 minus 1, which should be 5. So here you can see your y is equal to 5. And does this match with the y coordinate? Yes, it does. We have a 5 over here. So we've proved that any point that lies on this line is actually the solution for y is equal to x minus 1. So great job. So let's go to the next equation just to get a better understanding. Let's go for a nice purple color. All right. This is 3x minus 2y is equal to 6. Now, another interesting fact is that you only need 2 points to actually plot a line. So let's just take 2 of them. So let's take x as 1. Or rather, let's take x as 2. So it'll be 3 into 2. And you will get your y value, which will be 0. And let's take your x value as 0 this time. And let's take the y value as minus 3, which will equate it to 6 and 6. And now let's again plot this. So 2, 0 would be right around here. And 0, minus 3 right around here. All right, so let's get out our plotting tool. Let's actually plot this line and see what is the solution. So here is the line. And this is our solution for the equation 3x minus 2y is equal to 6. So let's do one thing. Let's plot a point again just to cross verify. So as you can see, the point minus 2 comma minus 6 actually lies on this line. So let's substitute the value of x and y and see whether this equates to 6. So it'll be 3 into minus 2 minus, it'll be minus 2, 2, and it's going to be minus 6 over here. So what you're going to get over here is 3 into minus 2 is minus 6, and 2 into minus 6 is minus 12. You multiply it with the sign that is over there. So you'll get a plus 12 right over here. And minus 6 plus 12, you get the value as plus 6. And hence you have proved that this point is a solution for the equation 3x minus 2y is equal to 6. Great. So can you call any equation a linear equation? The short answer to that is no, you cannot. There are you have a specific set of parameters that you can actually, through which you can call an equation a linear equation. So let's go ahead and just check out what is actually not a linear equation. So let's go with an orange. All right, so x to the power 2 into y is equal to 4 is not a linear equation. Another example is 1 upon x plus y is equal to 20 is again not a linear equation. So what are the parameters that actually say that the linear equation is 1? So let's come back to our example over here. Y is equal to x minus 1. So what we are supposed to do is, the first rule is that you should have the variable value, the exponent of the variable value should be 1. As you can see, y is raised to power 1. X is also raised to power 1. And same is the case over here, x raised to power 1 and y raised to power 1 as well. In this example, you have x raised to power 2, which negates the thinking that this is a linear equation. And same is the case with this. You have x raised to power minus 1 because it's 1 upon x, so it'll be x raised to power minus 1. So you cannot call this a linear equation. Another example that is not a linear equation is when you multiply the variables. So let's say you have an equation called x into y is equal to 5. This is not a linear equation because you cannot multiply the variables. In these two cases, your variables are not multiplied, they're separate. Your variables are separate. And what you can do with the variables is that you can multiply some constant to the variables. As you can see, 2 right over here is being multiplied to x, and 2 right over here is being multiplied to y, and 3 is being multiplied to x. So these are the rules that actually tell you what a linear equation is. But just to give you a complete recap, any linear equation will have a solution that is a line in the graph, and any point on that graph is going to be a solution for your linear equation. And you have infinitely many solutions for one particular linear equation. Thank you.